So here we have x squared times sine of 2x. I see a multiplication of functions. I'm thinking parts, and I'm thinking this is parts type 1, where I let u equal the x guy and dv equal the trig. So du is derivative. dv to v is antiderivative, so I'm talking La Jolla theorem to take the antiderivative. And so I'll get a 1/2, and I know it's going to be negative cosine. So I put it together, so I get u v minus the integral of v du. All right, so I'm going to take the time to fix this. So the 2's will cancel, and the two negatives will make a positive. I'm just going to put this x in the front, and I stop and evaluate. So I still have an x times a trig function. Before it was x squared, now it's x to the 1. It's getting better, so I'm going in the right direction. So I want to let u equal the x guy again. dv is the cosine of 2x. du is 2x. La Jolla theorem again. So this one's relatively nice in that there's no numbers or anything to worry about carrying along, right? So I just get to do parts on this. So I get uv minus the integral of v du. Okay, so carrying everything along, I see that I can take the antiderivative of this last, right? So I'd have a negative 1/2. Antiderivative of sine of 2x will give me another negative 1/2 cosine of 2x plus a c. All right, so let's looking at this. So I have polynomial over polynomial. The degree of the numerator is smaller than the degree of the denominator. So I'm thinking partial fractions are, it's ready to go for it. I just need to factor the denominator out. So it looks like that. So this is a linear factor, so I get an a over an x. This is an irreducible quadratic, so I get a bx plus c. Okay, so here's where I multiply both sides by this denominator. So x times x squared plus 4. Okay, so these cancel. So this left-hand side, I'm left with this. When I multiply this times this, I get a times x squared plus 4. And then when I multiply this times this, I get plus bx plus c times x. So be really careful with parentheses here. Okay, so we always want to choose wise numbers if there is any, and there is. Let's let x equal 0. So if I let x equal 0, that's 0 and that's 0, so I get 4 on the left-hand side. If I let x equal 0, I get 4a, so here I get a equal 1. That's nice. Okay, so there's no other wise numbers to choose. So I need to compare coefficients. So let's look at x squared terms, right? On the left-hand side, I'd have 2. On the right-hand side, I know a is 1, so I'd have a 1x squared. And from this term here, if I multiplied it out, I would get a bx squared. So that means b must be 1. All right, so that's all I'm looking for is c, and so I see c is in front of an x term, right? So this would be bx squared plus cx. So if I'm looking at x terms, on the left-hand side, I would get just a c, cx. There's no x terms here. And on this left-hand side, left-hand side, that's right, I get a negative 1. So now I have all of the numbers. So let's put them all back in. So I'd have 1 over x plus, and then remember I'm putting it into here, b 1x minus 1 over x squared plus 4 dx. Okay, so this integral here is super easy. So let's just do it. This one here, I want to take the time and split it up. to two separate integrals. Oops, I guess I don't need to do like all the way two separate, right? I can just do this. So I'm separating it around the subtraction. And then if I wanted to, I could go further and say, okay, what do I do with this one? And what do I do with this one? So as many times as you need to rewrite it, do it. Okay, this one here needs a u substitution. So let me do it right here. So I would let u equal the denominator. So I get 1/2 du is x dx. So carry this part along. So I get 1/2 1 over u du. This here is my arctangent, which you're very familiar with. And then to put the ln in here, ln of x squared plus 4 minus, shoo,